Good morning, everyone. I hope you got over yesterday. I know there was a lot of information talking about numerators, the number on top, denominators, the number on the bottom, talking about improper fractions where the numerator is greater than the denominator, and talking about mixed fractions when we separated out the fraction, the improper fraction, into a whole and a fraction. So quite a lot of information yesterday. Hopefully you're comfortable with all of that information before you started today's lesson. We're going to look a little bit more at improper fractions and mixed numbers. And by the end of today, we really want to be able to be confident and comfortable and efficient. That means able to do it quickly and correctly, being able to switch between mixed and improper, improper and mixed. So, here's the kind of question that you see quite a lot when you move up the school into secondary school in tests. And they've done all sorts of funny things here. We've got 1/10, 6/10, 1 1/5, and then 3. So on this scale, we've got arrows that are in tenths, in fifths, we've got whole numbers, and we've got mixed fractions, as well as having some proper fractions. They're not improper because the numerator is smaller than the denominator. And the question is this possible? Are these fractions and whole numbers and mixed fractions, are they in the right place? So to do this, you've got to understand loads of different things. But none of them are complicated. It's just the fact that there is so much going on. To start with, we need to think about this 0 to 1. It starts to feel complicated because we're talking about numbers. If we were talking about cakes, and I said, is 1/10 of a cake going to be less than 6/10 of a cake? It wouldn't be confusing at all. But because we're putting it on a number line, we suddenly forget to think about this in a visual way. And just like with everything, thinking about sweets makes it easier. So let's think about it. Rather than as 0 to 1, let's think about, is 1/10 of a bar of chocolate going to go in here? If this is 1 bar of chocolate, well, let's just look over here for a second. Just look at the orange bar. Because what I've done in this orange bar is replicated the 1 interval, 2 intervals, 3 intervals, 4 intervals, 5 intervals. We've got 1, 2, 3, 4, 5. And together those 5 sections make up a whole, one whole. Well, if I wanted to split this into tenths, rather than the 5 pieces I've got it here, I'm going to need to, let's just grab some of these. I need to split each of these in half. It's not very neat, I know, but needs must. So now I've got, let's go back to full screen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My chocolate bar, my whole, is now split into 10. Well, let's think about that. Is 1/10 going to go before that first interval? Well, yeah, because that was the first interval there, because this 1 was split into fifths. And I know that 1/10 is halfway between there because that first interval was 2/10. The next one was 4/10, 6/10, 8/10, 10/10. So where does my 6/10 fit in? Well, 2, 4, 6. So that's right. 2, 4, 6. Then I get to my 1 whole. This is where it gets tricky because we've switched to fifths again. Well, here's my 1 whole, 10/10, 1 whole, 5/5, whatever you want to call it. And then here's my extra 1/5. It's on that first interval because this number line is still in intervals of fifths. So this is 1 whole and 1 extra fifth. I could have said 1 whole and 2/10. That would also have been true. And then finally, we know this is 3. This is 3 wholes. I could write it as 3 over 3. No, I couldn't. I could write it as 9 over 3. I could change that to fifths. and have 15 fifths. I could have that in tenths and have 30 tenths. But for it to be 3 wholes, whatever my denominator would need to be would have to be times by 3 to show that it's 3 wholes. Right. That's basically what we've just talked about. Let's jump down. So 15 fifths. 15 fifths. How would I write that as a mixed fraction? I've got 15 fifths. Brilliant. Lots of you have seen that would be 3, because each of these fifths is 1 whole. That's 1 whole, 2 wholes, 3 wholes. So 15 pieces, when an item is split into 5 pieces, means that the first 5 of those makes 1 whole. The second 5 makes 2 wholes. The third 5 makes 3 wholes. Right. Now we get back to that simplest form. We talked a bit about that yesterday. Simplest form means making it into the lowest possible amount. So I've got 6 tenths. Over here is my chocolate bar, my whole split into 10 pieces. 6 of them are coloured in. And I want to find a smaller way of representing that is equivalent, that is equal. It's the same amount of chocolate that I'm going to eat. I could have 6 tenths of a bar where my bar is split into 10 pieces, or I could have a different amount. So in this case, all we've done is made each of these 2 tenths into 1/5. I've divided 10 by 2 to get it to 5. And whatever I do to my denominator, I do exactly the same to my numerator. 10 divided by 2 is 5. 6 divided by 2 is 3. My chocolate bar is now the same size, but it's split into 5 pieces, not 10. And rather than having 6, I now have 3. So 3/5 of a chocolate bar is exactly the same amount as 10/5 of that same chocolate bar. Some people would get confused and think, oh, there's 10 pieces, there must be more. But actually, that's not the case. If something's split into more pieces, the pieces get smaller. Picture a cake for a minute, or a pizza. If you split it into 2 pieces, they're big pieces. Split it into 4 pieces, they get smaller. Split it into 8 pieces, they get smaller. Split it into 100 pieces, they get really small. The more pieces we split it into, the smaller that piece is. Okay. So our task here is to turn a mixed number into an improper fraction. So we're going to start with 3 2/3. We're dealing in thirds. So what I've got is my whole, my second whole, and my third whole. That's my 3s. And I've split them each into thirds because I know that my final answer is all going to be in thirds. So my 1 whole is 1, 2, 3 thirds. My 2 whole is another 3 thirds. That means I've got 1, 2, 3, 4, 5, 6 thirds so far. But I've got 3 wholes, another 3 thirds. So that's 7, 8, and 9. So these 3 wholes are the same as 9 thirds. I can draw it out like this. You might have realized that I can times my 3 by the denominator. 3 wholes split into 3 parts is the same as 3 times 3. So I know that 3 wholes is 9 thirds. But I also had this 2 thirds here. So I add that to my 9, 10, and 11. So 3 2/3 is the same as 11 thirds. Pause this video for a moment and have a look at 4. What's 4 going to be in thirds? Brilliant. Hopefully you've realized that it's 4 times 3 because I'm going to take each of those 4 wholes and split them into thirds. So it'll be 3, 6. Oh, what am I doing? 4. Yeah, 3, 6, 9, 12. So I'm going to have 12 thirds. Have a try with question C. 4 wholes split into quarters into fourths. How many fourths will I have? Well, each of those wholes is going to be split into 4 parts. So I'm going to have 4 lots of 4. So 4, 8, 12, 16. I'll have 16 fourths. 4 wholes is the same as 16 quarters. Right. Ooh. We're doing the opposite here. Now we're going from an improper fraction, 7/5, to a mixed number. Well, I've got 7/5 here. 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5. I'm just going to put them in order, and I'm going to put them in order of fifths because I know that I'm dealing with fifths. So here is 5/5. 1, 2, 3, 4, 5. I know that's the same as 1 whole, which means I'm then left with 2/5. So 7/5. Once I've taken away 5 from 7, I'm left with 2. So I know my answer is 1 whole and 2/5. Have a try with 7 thirds. Well, this time, each of these pieces is going to be a third. And what I know is that if I put them into groups of 3, I've got 1, 2, 3, 4, 5, 6. There's 1 whole, 1. Another whole, 2. So 7 thirds becomes 2 wholes with 1 third left over. Because when I had 7 pieces and I grouped them into 3s, I was able to make 1 group of 3, 2 groups of 3, with 1 third remaining. Ooh, oh no, that's fine. And then we've got another type of question here. It's very similar. It's writing 3 8/10 in its simplest form. In this instance, I'm going to leave 3 as it is. And so I'm just looking at 8/10. Can I simplify 8/10? Well, I know that I can halve 8 and I can halve 10. So I could make that 4/5. Could I do anything else? I know I can divide 8 by 4 to get 2. Can I divide 10 by 4? Not really, because I'd end up with a decimal. And remember from yesterday's lesson, we don't have decimals in fractions. They have to be whole numbers. So 3 4/5 would be my simplest form. What about 8/12? What's the simplest way of expressing 8/12? Excellent. Lots of you will have guessed you can halve it. I could say 4/6. That would be absolutely right. But I can divide 8 by 4. And I can also divide 12 by 4. If I divided 8 by 4, that would be 2. And if I divided 12 by 4, that would be 3. So 2 thirds would be the simplest form. Don't worry if you went straight for 4 over 6. Totally understandable. It's a trick question to see if that's what you would do. You've got to remember not to always assume that halving is going to be the way to find the simplest form. Okay, you weren't supposed to see that. I'm going to ask you to go to the worksheet now. Complete the worksheet. Once you've completed the worksheet, can you please come back to the video? And just like yesterday, I'd like you to mark your answers. So pause the video now. You're going to the next worksheet on the printouts, the pages, sorry, on the PDF file in the class story. The next worksheet, they're not in your textbook. I just realized I said in your textbook yesterday, but they're not. because this is the last lesson from the last textbook. Once you're ready, you can play the video and check your answers. Okay, you should have paused your answers now. I'm not going to talk these through in detail. I'm just going to put the answers up here. Let's just look at the first section. You might want to pause the video while you check your answers. And then the second section. I haven't put the answers up for the first page. I'm fairly confident you can do that by yourself. Brilliant. Well done today, guys. There was a lot in that lesson. So well done with sticking through it. See you tomorrow.